Okay, let's get started up again. So now we're going to move on to the IPCC report. So we talked about the IPCC in a few previous classes, the Intergovernmental Panel on Climate Change, basically the UN bringing together the top climate scientists to publish reports. So they just published one last weekend. So this wasn't one of the major climate reports that we've been talking about. This was actually a special report. So basically, the Paris Climate Agreements sets a target of no more than 2 degrees Celsius global warming above pre-industrial temperatures, but they also had an aspirational target. They would prefer that we stay no more than 1.5 degrees Celsius above pre-industrial temperatures. And so the UN basically asked the IPCC to publish this report to both talk about what it would take for us to meet the 1.5 degrees C target in terms of reducing greenhouse gas emissions and in terms of our carbon budget, and also what the difference in impacts would be between a 1.5 degree warming world and a 2 degree C warming world. And so it turns out there hadn't been a lot of research published looking at impacts at 1.5 degrees Celsius because, I mean, for one thing, it's going to be very, very, very hard for us to meet 1.5 degrees Celsius. And so climate scientists tend to look at more realistic scenarios like 2 degrees, 3 degrees, 4 degrees, and more. And so they had to look at all the research that had been published on 1.5 degrees Celsius. I think there has been some recent research on this since the Paris Agreement was made. Then there's been more research looking into what a 1.5 degrees Celsius warming world would look like. And so they published this report. So we're just going to talk about this a little bit. Next week we're talking about impacts. This is just kind of some impacts leading into next week's lecture. So as I mentioned, one component of the study was figuring out what our carbon budget looks like if we're going to meet the 1.5 degrees Celsius target. So this chart was one of the figures published in the IPCC reports, the special reports. And so you can see kind of the gray and the yellow line is how much we've warmed so far. And then that gray line across the top or in the middle is the 1.5 degrees C target. And then they have 2 degrees at the very top of the charts. And they have kind of these 3 different sort of scenarios that are possible pathways we could take to meet that 1.5 degrees target. And so the gray envelope in the middle, the colors are kind of similar, but there's a gray one in the middle. And that's looking at basically if we reduce the non-carbon greenhouse gas emissions, so the methane, the chlorofluorocarbons, the other non-carbon greenhouse gas emissions, we reduce those down to basically close to 0 by 2030. So we basically really quickly get those under control. If we do that, and then we reduce carbon emissions down to 0 at about 2055. So if we do that and do other things, they also talked a lot about basically negative carbon emissions, which is basically capturing carbon out of the atmosphere and storing it, both with afforestation, planting more trees, and also technology, building plants that suck a lot of air, capture carbon, and liquefy it, and then store it. So there's a lot in order to meet the 1.5 degrees C target. There is both reducing emissions down to 0 by around 2040, 2050, and then also storing a lot of this carbon and sequestering it over the long term. So that's the gray one, and the blue one a little bit lower at the bottom, as if we do it even faster, reduce carbon emissions down to 0 by 2040. That gives us a little bit better chance of staying below 1.5 degrees Celsius. And then the sort of purplish, pinkish one at the top, that's if we don't get the non-carbon greenhouse gas emissions under control and we just reduce carbon emissions. In that case, it's much harder for us to meet that 1.5 degree target. It's still possible, but again, you have to do a lot of this. First of all, you have to reduce carbon emissions really fast, and then also you have to get a lot of carbon out of the atmosphere through planting forests and sequestering it and technologies and other ways. So basically, you have to get carbon emissions down to 0 by mid-century if you're going to meet 1.5 degrees Celsius, and you have to have all these ways of pulling carbon dioxide out of the atmosphere. Basically, it's like super, super, super hard to meet 1.5 degrees Celsius. Our carbon budget, we have about 3 to 10 years left before we burn through the remaining carbon budget for the amount of carbon that can be in the atmosphere to limit warming to 1.5 degrees Celsius. So that's why only 3 to 10 years. That's why we're not going to get carbon emissions down to 0 in 3 to 10 years. That's why you also need to pull the carbon out of the atmosphere and store it. And so my personal opinion is that this is not going to happen because carbon emissions globally are still going up. So there's this other chart that they published along with that one. This is what carbon emissions have to look like to meet the 1.5 degrees C target. So you can see they're going up. They're starting to flatten out a little bit in recent years, but basically you have to go spiking downwards really fast if we're going to stay below the 1.5 degrees C target. So a very hard thing to do. It's not physically impossible. It's just politically, it's kind of hard to see that happening. So that's kind of my takeaway from that. So this is a chart from, there's this good site called the Climate Action Tracker that's kind of, they track all of the pledges made by countries all around the world and their existing policies for how much they're going to reduce greenhouse gas emissions. So basically on this chart, the gray is like if countries just kept on going with business as usual and didn't implement any climate policies, we'd see over 4 degrees Celsius warming by 2100. Based on current policies, we're at about 3.4 degrees Celsius warming by 2100. Based on additional pledges that countries have made but haven't followed through on reducing their emissions yet, we're going to be around 2.8 degrees Celsius by 2100. So basically, currently we're on track for around 3.4 degrees Celsius warming by 2100. And so we have to do a lot more than we're doing right now to get down to 2 degrees or 1.5 degrees. So basically, if we did, like if the world did decide, okay, we really want to stay below 1.5 degrees, it would basically take like a World War II effort of deploying low carbon technologies all around the world and a development of these technologies to pull carbon out of the atmosphere and sequester it. So like I said, realistically, 1.5 degrees is not going to happen. I think 2 degrees is like the best we can realistically hope to limit global warming to, and even that is going to take like serious global efforts to do more than what we're already doing to reduce our carbon emissions and other greenhouse gas emissions. Yes? Converting to Fahrenheit, so basically 3.4 degrees is what we're looking at happening Celsius by 2100. That's about 6.3 degrees Fahrenheit is the current pathway we're on right now. If we were to limit to 2 degrees Celsius, that's about 3.5 degrees Fahrenheit, I believe. And then 1.5 degrees Celsius is like 2-point-something degrees Fahrenheit. So then they looked at some impacts, and I actually pulled these charts. There's a really good site called Carbon Brief that had, just before the IPCC report was published, they had done the same thing. They looked at 70 peer-reviewed papers that have been recently published looking at the difference in impacts between 1.5 and 2 degrees Celsius and sometimes higher degrees. So I just pulled a few of these off of their site because they're nice little graphics showing the differences in impacts, these different temperature thresholds. And so the first one here is in Arctic sea ice. So basically we talked about, last week we talked about how quickly the Arctic sea ice is disappearing. So at some point there will likely be a summer starting where there is no more sea ice in the Arctic by the end of the summer because it melts throughout the summer. And so we call it the Arctic sea ice free summer. And so the likelihood of this happening, if we limit global warming to 1.5 degrees Celsius, there's only about a 10% chance of an Arctic free summer, Arctic ice free summer by the time we hit that 1.5 degrees Celsius. So it's not too likely to happen. And in a given year, there's only about a 3% chance of it happening. So basically, if we limit global warming to 1.5 degrees Celsius, there will still be some Arctic sea ice left in the summer. If we go to 2 degrees Celsius, at that point, it becomes much more likely. There's an 80% chance of a sea ice free Arctic summer by the time we hit 2 degrees Celsius. And each year has about a 16% chance of being sea ice free in the summer in the Arctic. And then if we get to 3 degrees Celsius, there's basically a 100% chance we're definitely going to have these sea ice free summers in the Arctic if we reach 3 degrees Celsius. And in a given year, there's a 63% chance of it happening. So basically, more often than not, in the summer, if we reach 3 degrees Celsius, there will be no Arctic sea ice left in the summer. So then we also have some heat wave research. So not surprisingly, as you get hotter temperatures, you're going to get more and stronger heat waves. And so there was a paper that basically categorized them as severe heat wave and extreme heat waves, which they had their own heat wave index, so it's complicated, but basically they have these different categories. And so at 1.5 degrees Celsius, about 14% of the global population is going to have at least one severe heat wave every 5 years. Once you get up to 2 degrees Celsius, it gets up to 37% of the population having severe heat waves pretty frequently every 5 years. And then every 20 years at 1.5 degrees Celsius, even at that relatively low level of global warming, you still get half the population getting at least one severe heat wave every 20 years. And then at 2 degrees Celsius, that goes up to 70% of the population getting a severe heat wave at least every 20 years. And then they have even worse, the extreme heat waves, where it's really, really hot and really, really long heat waves. In that case, at 1.5 degrees Celsius, there's about 9% of the population getting these severe heat waves, extreme heat waves every 20 years. But if you get up to 2 degrees Celsius, that triples, and it's up to 28% of the global population having an extreme heat wave, or one or more, every 20 years. So like I said, they have a very complicated, their own categories of what's an extreme and a severe heat wave, so I couldn't even translate it into degrees. I was trying to figure it out, but they have their own index. So it's like based on their index, so it's very complicated. But yeah, I mean, probably, people die generally in heat waves just because like some people are less adaptable, particularly really old people who are already sick. Then it's harder for them to adapt, or if they don't have air conditioning available, for example. So countries with more poor poverty in the population, they have less ability to adapt. And so yes, like the more extreme a heat wave is, the more people will die. So like the severe heat wave will have fewer deaths than the extreme heat wave, but in any case, there's usually people who die during severe heat waves. So then the last one I got is the impacts on drought. And so basically they have when there is a drought at 1.5 degrees Celsius, on average it'll last about 2 months. When you get to 2 degrees Celsius, that doubles to 4 months. So basically droughts are getting longer. They're also getting more intense and creating more water scarcity. So at 1.5 degrees Celsius, there's about 271 million people globally who will be exposed to water scarcity. That increases to 388 million if you go up to 2 degrees Celsius. And then the population exposed to severe drought is kind of a similar story. You get 132 million at 1.5 degrees Celsius. That increases to almost 200 million people being exposed to severe drought at 2 degrees Celsius. So basically, the big term picture is that at 1.5 degrees Celsius, there's some pretty severe climate change impacts. But basically, the more warmer you get beyond 1.5 degrees Celsius, the worse the impacts get. So 2 degrees Celsius is worse than 1.5 degrees Celsius. But then 2.5 is worse than 2, 3 is worse than 2.5. So basically, the more warmer you get, the worse the impacts get. And so I'm actually working on a piece for The Guardian on Monday about this report, and kind of my take-home point is that the one thing to get from this report is that we need to reduce carbon emissions as quickly as possible and as much as possible. And that is always true. Even if you miss the 1.5 degree target, you still want to hit the 2 degrees Celsius target. Even if you miss the 2 degrees Celsius target, you're better at 2.5 degrees than you are at 3 degrees. And so really, it's never the case that this is untrue. It's always true that you want to reduce emissions as fast as possible, as much as possible. And that's really the take-home point. You can look at it's kind of interesting to look at the specific impacts and the differences between 1.5 and 2 degrees Celsius. But really, the bottom line is we need to reduce emissions as fast as we can to get as close to these targets as we can get. Question?
I was just thinking that intuitively these drought impact us very conservatively.
Yeah, I mean, so the point is that if you consider that the high populations of places like India and Central Africa, that it seems like these numbers are quite conservative because those places tend to get significant droughts. So, I mean, I haven't looked at this particular study. It's based on this one study that was just looking at the impacts between 1.5 and 2 degrees Celsius. So I can't really comment on that particular study, but I mean, it's always possible that it's an underestimate. I can't, You have to look at the details about how they calculated this. So I think that's all for the lecture, and now we can just do the Q&A session since there seemed to already be a lot of questions. So let me just turn the lights real quick.